Hi guys, this is lesson 2.7. It's about percent of change. You can find the lesson on page 119. There's lots of good examples worked out for you. And basically we're going to talk about percent of increase, percent of decrease, and a general idea where we keep seeing words that we can translate into math, like of means times. So let me show you some examples of percent problems. Look at example or problem number 1 on page 121. If our original is 78 and our new is 125, and we are supposed to state whether each percent of change is a percent of increase or a percent of decrease, and then find the percent of change and round it to the nearest whole percent. Here's what we're going to do. So you can tell that if the new is 125 and the old is 78, that this is a percent of increase, right? We are going to do this formula right here, which we find in a lot of statistics problems. There's a lot of problems that kind of go like this. We do the new minus the original, that's the change, and then we're going to divide by the original to get the percent. So here we're going to do 125 minus 78, and then we're going to divide that by 78. We can do all of this in the calculator. So 125 minus 78 is 47, and then I'm just going to hit divided by 78, which gives me 0.6025, yada yada yada, long irrational number there. It asks me to round this. If I see a decimal, decimals to percents, we just move it to spaces like this. We will call this 60% because 2 is not going to be big enough to bump that up to 61. So we're going to call this a 60% increase because we went up. Okay, let's do number 2. Our original is 41 and our new is 24. And so we can see that since our new is 24, this is a decrease because it is less than the original at 41. But we're going to do the new 24 minus 41. See, that gives us a negative number that'll tell us decrease also. And we're going to divide that by our original of 41. So in the calculator, we go 24 minus 41 equals negative 17. We're going to hit divided by 41, and we get a negative 0.4146, and there's more number there. We're not going to really keep this negative, but it is telling me that it's going down. I'm going to round this. When I go 2 decimals, this number right here is not big enough to round us up, so we're going to call this a 41% decrease. All right, let's go on now to, let's do number 5. It's a little tricky because they give you the percent and you have to figure this out. The distance from Phoenix to Tucson, so we have a distance that is 120 miles. That's our original. And then it says that the distance from Phoenix to Flagstaff is about 21.7% longer, so it's an increase. And we actually have to find out what the distance from Phoenix to Flagstaff is. So this is Flagstaff, or Phoenix to Tucson, and we want to know Phoenix to Flagstaff. And so if I want to say what is 21.7% of 120, because I can add that to, let's add that on to 120 to get our Phoenix to Flagstaff. So the word of here is times, and it will save you a whole lot of times if you're not sure exactly what to do. Of means times. 21.7 is 0.217, so we have to go back to that decimal, right, by going backward 2 spaces like that. And we're going to hit times 120, That's the distance. That's the distance that is the difference between the two. 26.04. We're going to add 26.04 plus 120 to get 146.04. And it says to the nearest mile. So I'm going to answer that 146 miles. I said some of that out loud without writing it down. So hopefully you were listening. All right, let's look at number 6. If I have a dress that costs $22.50 and there is tax of 7.5%, I want to know the total price, I can calculate the tax and I can add that on. And so the tax as a decimal is going to be 0.075. So remember, with percents, we're always moving our decimal 2 spaces. And I want to know what 0.075 of 2250 is. So I'm going to multiply that together. I'm going to show you a shortcut in just a minute. I'm going to use x for times in this situation. Okay, so we're going to multiply this 2250 times 0.075, and I get 1.6875. Okay, nobody charges money past 2 decimals, right? So the money's going to be here, but everybody will round up. So this will be $1.69 tax. Okay, so total price is going to be $22.50 plus $1.69, and I can just add that together in my calculator, and I get $24.19 for a total price. That's the exact price I have to pay after the tax. I'm going to show you a little shortcut. If this confuses you, just cover your ears and don't listen. But some of you will really understand this. If I multiply 2250 times 1.075, what the 1 is going to do for me is add in the original 22.5, that original price that I had to add back to the tax to get the final answer. This is going to do it all in one step. Watch what happens in your calculator if you go 22.5 times 1.075. The 0.075 is still the tax. And then when I get that, I get 24.1875, and I can round that to still be $24.19. It's kind of nifty, and we will see it in some interest equations, some formulas that we actually have later on. But if we're doing an increase like that with the tax, we know we still have to pay this original and we have to pay this tax. So if I put this 1 on here, I only have to do 1 step. It's okay if you're doing it such that you calculate the tax and then you add it on, that's fine. All right, maybe you try the video game in number 7. Okay, I want to do this 1 times 1.0675. That's going to give me my final price, $35.99 times 1.0675, and that gives me $38 and 0.419325. So we're going to call that 42 cents. We always round up there. And that'll be the price of that video game. Okay, now if you covered your ears and you didn't want to talk about this one, then what you did was you took $35.99 times 0.0675 to get the tax. And that number is $35.99 times 0.0675. The number is $2, and I'm rounding 0.429 to 0.43, $2.43. We have to add that onto my original price, and then we will get the same answer right here. All right, let's go down now and look at number 10. This is a discount, okay? So I have a guitar that costs $95 and it's discounted 0.15. Actually, I just said that it's 15% and I converted it without thinking very much right there. So when I calculate this, when I do 0.15 of $95, I'm going to get what the discount is. I'm going to show you this from a couple angles. 95 times 0.15 is $14.25. I'm going to save $14.25. Okay, so that's pretty cool. I can take $95 and subtract the discount to get the price I'm going to pay. $95 minus 14.25 is $80.75. Okay, is there a one-step way to do this? Yes, there is. Okay, if I'm being discounted 15%, that means I'm actually going to pay how much? Think about it. If you're discounting 15%, what's the other part of 100% that you're going to have to pay? Is 85%. You actually have to pay 85% of that. 85% of $95, we multiply 0.85 times 95, and we get $80.75. All in one step. So it's kind of cool. Think about what you actually pay, not just what is the discount. So that's kind of a cool thing when we're discounting something. So you do number 11. The DVD is $22.95 and the discount is 25%. So how much are you going to pay? Less than $25.95 or $22.95, right? So then I can subtract $22.95 minus $5.74 is going to give me $5.74 is $17.21 is my new price, okay? Let's try it the other way. If I am discounting 25%, that means I am actually paying 75% of the original price. So I'm going to do 0.75 of $22.95 and save myself the subtraction. 0.75 times 22.95 is 17.2125, and I will round that to 1721. Okay, hopefully you are tapping these into your calculator right along with me so that you get the reinforcement and the practice for that. So what did we learn today? We learned that new minus original divided by original will give us percent of change, whether it's an increase or a decrease. We learned that of means multiply. For example, what is 30% of 250 can be translated into 0.30 times 250 equals. And we learned that discounts and the amount you pay add up to be 100%. For example, if the discount is 15%, you're actually going to pay 85%. Those two amounts will equal 100%. We learned that you have to be careful and look at what they're actually asking you. Questions might be, what is the total cost? Or how much will you save? Or what is the discounted price? So really read the questions and really think about what they mean. You've been shopping, so you have a sense of this deep down if you just give yourself a chance to think about it.